In this video, I will try to give a simple explanation of Kirchhoff's junction rule. Kirchhoff's junction rule, which is also known as Kirchhoff's first law, says the sum of all currents flowing into a junction is equal to the sum of all currents flowing out of the junction. Mathematically, we can express it this way, where the Greek letter sigma, which is circled in red, means the sum of. This equation is stating that if we add up all the currents into a junction, it must equal to the sum of all the currents out of the junction. Let's consider the following example, where the junction is marked by a red circle. We have 5 currents. Of those, I1, I3, and I4 are flowing into the junction, and I2 and I5 are flowing out. Applying the junction rule, we get I1 plus I3 plus I4 is equal to I2 plus I5. The junction rule is one of the fundamental principles in circuit analysis, and it is based on the conservation of electric charge. Electric current is the flow of electric charge. Because the electric charge cannot be created or destroyed, if a certain amount of charge flows into a junction each second, then the same amount of charge must flow out of it each second. Let's consider the example again, but this time we will assume that I1 is equal to 2 amperes, I2 is equal to 3 amperes, I3 is 1 ampere, I4 is 5 amperes. We don't know what I5 is, but we can find it out using the junction rule. On the left-hand side of the junction rule, we need to add up all the currents into the junction, which is 2 amperes plus 1 ampere plus 5 amperes. On the right-hand side of the junction rule equation, we have the sum of currents out, which is 3 amperes plus I5. Simplifying the left-hand side, we get 8 amperes is equal to 3 amperes plus I5. We can solve it for I5 and get I5 is equal to 8 amperes minus 3 amperes, or 5 amperes. Let's consider a slightly different situation. We will keep the values of I1, I3, and I4 the same as before, but make I2 10 amperes. Then, using the same approach as above, we find that I5 is negative 2 amperes. What the negative sign is telling us is that the actual current flows in the opposite direction, so it flows into the junction.